So isn't
All
this
right.
a homework?
Yes. Okay. Let's take a look at today's lesson. So today's lesson on trig equations, we actually have 2 days on trig equations. There are 2 different sets of slides that we're going to be working through, but the concept is the same. We want to solve the trig equations, and we've talked about that word before, right? What does solve mean? Do we remember? What is solve? That means find the value for x or variable, right? That's what solve is. So that's kind of our goal here. We want to find that out. So let's go through our particulars. Okay, so the first thing we want to notice is that it says all solutions. All solutions. What does that mean? This means that we want the function values, the function solutions, and the relation. Okay, function and relation solutions. We want all of them. And there's a particular way that we write all when we're working, when we get our answer to the problem. There's a particular way that we write all. And so we will talk about that as well. So so this means that we want the functions and relations. Okay, so what do? We solve for the variable. So I'm going to move the root 3 over. So 2 sine theta equals negative root 3. And then divide by 2. Sine theta is negative root 3 over 2. Okay, great. So let's think about, so unit circle is very important to us in this unit and last unit and the next unit. This is one of our, non-negotiables. We've got to get that memorized. So let's kind of think about where this would be. So sine is mapped to the y. It's mapped to the y value. Sine, the y value for, in our first for quadrant 1, 2, 3, 4, y values are negative in which quadrants? The third and the fourth. We're looking for third and the fourth. And I want the y value to be bigger. Remember, we've had this discussion before that root 3 over 2 is bigger than 1/2. We want the y value to be bigger. So what we're looking at this angle measure and this angle measure. That's what we want. It lies flatter against the y-axis than the x-axis. And so the root 3 over 2 and 1/2, those are 30, 60, 90s, and we're just going to count around our, by 6. Remember, you're probably so tired of hearing me say that. We have 30, 60, 90s, we count around by 6, 45, 45, 90s, we count around by fourths, and that's how we find our radian measure. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, and 10 pi over 6. Okay, those are the angle measures that satisfy that criteria. So we really need to pay attention to the period, and we've had quite a bit of experience with that, finding the period. For this particular function, just sine of theta, the period is 1, right, because b is 1. So the period is 2 pi. Okay, let's keep that in mind. So we're going to write our answer. So theta equals, I'm going to reduce 8 pi over 6 to 4 pi over 3, plus our period is 2 pi n. Now let's talk about the n. And I have one more, I'll just write the other one because the second one would be theta equals 5. So 10 pi over 6 reduces to 5 pi over 3 plus 2 pi n. So let's talk about this notation right here. What in the world is going on with this notation? So this location, this part of it, is the period. And we know that depending on what the function looks like, the period could change, right? We've experienced that before. The period does not have to be 2 pi. It could be something different. When we were graphing, sometimes the period was like 12, right? We don't know. So that's going to be the period of the function. We're going to need to check. We need to check. So we need to make sure there's a proper period. This n is just what n, let's see, do you remember back in Algebra 2 when we were looking at sequences and series, and the n in sequences and series was an integer? Remember that? That basically was a definition that n is an integer. It is also an integer here. It's an integer. It's 1 or 2 or 3 or -1 or something like that. So if we want to get to, let's say, 4 pi over 3 plus 2 pi, and n is 1 plus 2 pi, that would just take us to one of those coterminal angles. Remember that word from previously, coterminal? They're ending in the same place. So those are the things. So this n is an integer. The integer can be positive or negative. So you do not need to write plus or minus 2 pi n. There's no reason for that. It's just n. And so here is our answer, our very first answer. Okay, and what this is for is all. We're looking for all solutions. That's where we write the answer like this. And there are some in your homework that ask for all solutions. And you would, I think they use a k in the book, but the k means the same thing as an n. It's just an integer. Okay, are we okay so far? All right, so let's take a look at our next one. And I do want to talk about this one for a moment. Actually, number 2 and 3. I want to talk about those together. These two particular problems tend to confuse students sometimes, okay? And they actually are one of the easier ones to solve. So what I'm going to do is I'm going to write steps. I like steps. I don't know about y'all, but we need to know what do we do? What are the steps that we need to do? So here, we're not looking for all solutions. We're looking for the solutions between 0 and 2 pi. We have a restriction now. So instead of having an expression like that where, or an equation, theta equals those things, we're going to have a list of angle measures, a list when we have a restriction like that. So this is going to turn out to be a list of answers. Answers/angle measures. Okay, so let's start our list. So the first step, what we do with ones like this, is we're going to ignore the argument. Ignore the argument. So what do I mean by argument? This is the argument. We're going to ignore it. I'm going to just color code it. It's in yellow. We're going to ignore the argument and just locate where, in this case, where sine is 1/2. Okay, we're just going to look to see where sine is. We're not going to pay attention to what's inside the argument. We're just going to investigate to see where sine is 1/2. So let's do this one step at a time. So I've got my unit circle. I need to know where sine is 1/2. Okay, so sine is maps to the y and sine is positive. So we're in the first and second quadrant. Sine 1/2 is smaller, so these angle measures need to be flatter along the x-axis because the y is smaller. Okay, so they're flatter along there. And so 1/2 and root 3 over 2, we count in sixths. So this is 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. So we have ignored the argument and we just located where sine is 1/2. We see there are 2 places where sine is 1/2. So I want to pause here for a second. Is everybody okay? Okay. So step 2. We set the argument equal to the values we found. And I'm going to color code it again. The argument. We set the argument which is the 2 theta, equal to the values we found in step 1, and solve for x or theta, whichever one you want. Sorry about my writing. And solve for x or theta. Okay, so let's do that last, that's actually the last step. So I do 2 theta equals 5 pi over 6, and 2 theta equals pi over 6. Okay, which means I need to multiply both, divide both sides by 2 or multiply by a half. I would actually prefer to multiply by a half. It just seems easier than dividing by 2. You can do either one you want. You're going to get the same answer. So theta is 5 pi over 6 times 2 is 12, or theta is pi over 6 times 2 is 12. Now the caution here is, this is perfect. These are answers. But they want all the answers between 0 and 2 pi. So what do we do? So let's think about what this normal period is. So let's go up here. So this period, so the period equals 2 pi over b, which is 2. So this period is pi. So what does that mean? The period is pi. That means it makes one full cycle in the period pi. So there's another full cycle in another period of pi. So are we understanding what I'm saying? What I'm saying is that we need to go from 0 to 2 pi, not 0 to pi. So that means we should have twice as many answers. Does that make sense? Okay, because in one cycle, we're going to get 2 answers. In 2 cycles, we should get 4 answers. In 3 cycles, how many answers should we get? 6 answers. Okay? All right, so what physically do we do? Well, if the period is pi, what I would like to do, since we're in 12ths, and fractions are hard. Fractions are hard, right? What I would like to do is rewrite this in 12ths. So 0 is less than or equal to theta, less than or equal to, let's see, we're 12, so that would be what, 24 pi over 12. So the angles that we have written down there should be between 0 and 24 pi over 12. That's just helping us have a numeric guide for us. All right, so let's see, if I add pi, so I need to add pi. So I want to add pi, which is, 12 pi over 12, which is 12 pi over 12. I want to see what I get. Okay, I'm going to add pi. So 5 pi over 12 plus 12 pi over 12. What does that give me? 5 pi over 12 plus 12 pi over 12 gives me 17 pi over 12. Does that exist in this interval right here? Is 17 pi over 12 between 0 and 24 pi over 12? Yes, so it's an answer. Okay, so now I'm going to add 12 pi over 12 to pi over 12. So 1 pi over 12 plus 12 pi over 12 gives me 13 pi over 12. Is 13 pi over 12 between 0 and 24 pi over 12? Yes. So I have 4 answers, and that's what I should expect because my period is shrunk. My period has shrunk to pi, but I'm actually being asked for answers from 0 to 2 pi. Does that make sense? And if I were asked for answers for 0 to 3 pi, how many more answers should I have? 2 more. And if I were asked for answers from 0 to 4 pi, we understand how that's working, then I would get 4 more answers, right? Okay. Now, for the next one, the period has not changed. This is tangents period. So tangents period is pi. Okay. So we're going to do those steps because this is the same kind of thing. See how that argument is just kind of crazy looking? And I just want to know where tangent is 1. That's all I want to know. I want to know where tangent is 1. Okay, so let's work on that. So tangent being 1, if you recall, tangent is sine over cosine. And if it's 1, let's see, we want the numbers to be the same, right? Sine and cosine have to be the same number, so they divide to be 1. And where does that happen for us? Does it happen in 30, 60, 90s or 45, 45, 90s? 45, 45, 90s, because those are root 2 over 2, root 2 over 2, right? So, okay, great. So we want 45, 45, 90s, and we know that it's positive right here, right? At the first 45, 45, 90. Where else would sine be positive? Which quadrant would sine be positive in? The second quadrant, sine would be positive, yes, and cosine would be negative, very good. Where would tangent be positive? And the third quadrant, right, because they're both, sine and cosine are both negative. So we're right here. So here's my other value. So now let's count. Okay, so we have 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. So we did step 1, we ignored the argument, and we just located where, in this case, where tangent is 1. Now we're going to set the argument equal to the values. Okay, so theta minus pi over 2 equals pi over 4. And theta minus pi over 2 equals 5 pi over 4. Yay, fractions, right? Y'all are like, yay, fractions. You're like, probably no, please. All right, so I need common denominators because that's how fractions work. So I'm going to change pi over 2 to be 2 pi over 4. And it's really easy to erase on here. I'm just going to change it to be 2 pi over 4 so it makes more sense. So that means theta would be, let's see, if I add that over, 1 pi over 4 plus 2 pi over 4 would be 3 pi over 4. And if I add that over, 5 pi over 4 plus 2 pi over 4 would be, what, 7 pi over 4. And here's my answers. So let's talk about the period. The period is pi. And I need to go from 0 to 2 pi. Okay, 0 to 2 pi. And so I have 2 answers. I have 2 answers. Yes, ma'am.
So did we have to solve for the period on number 2 because there was something in front of the theta?
Correct.
So other than that, we assume that it's 2.
Then it's just, yeah, if that had just been theta, then sine would have been 2 pi, and it'd have been much easier for us. Much easier. All right, so that is those types of questions. How are we doing on those? We okay? Okay, let's go to page 2. We've got a few more to work through. So far, all you've had to remember is unit circle. So far, that's all we've had to do to solve these. But there's more. You're like, yay, but there's more. Okay, so let's focus on number 4. So I want to get tangent by itself. So tangent squared equals 3. I want to square root both sides. Okay, I want you ladies to think back to last year. What is a very common mistake when we square root both sides? What do we need to remember to do? Plus minus. Plus minus. This is plus or minus root 3. Plus or minus root 3. Okay, so here we go with the root 3 stuff. We know tangent is sine over cosine. To get root 3, we would have to have the top number be root 3 over 2. So sine needs to be root 3 over 2. The bottom number needs to be a half. Remember the whole keep, change, flip. That's going to give me root 3. Okay, so let's draw our our unit circle here. Okay, let's think. So we want to know where, and it's positive or negative, so it's going to be in all four quadrants. We want to know where would sine be 3/2 and cosine be 1/2. That means that sine is going to be longer along, so that's the bigger one. That's going to be more flat along the y-axis because sine maps to y. And that's going to work basically in every single quadrant because it's all plus or minus. Okay. And those are 30, 60, 90s. So let's count. So we have 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and 12 pi over 6. So those are our numbers. But what I would like to talk about is, and this is asking for all. This is all. Okay, so what do we need to do? We need to do that plus thing. What is the normal period for tangent? Pi. So for tangent, the period equals pi. Okay, so let's just start with this first quadrant. So I would say x equals, let's see, 2 pi over 6 reduces to pi over 3 plus pi n. That's what they would want you to do. And I want to point something out to you. Okay, here, if I add pi to 2 pi over 6, I get 8 pi over 6. Both of those answers are included in that one statement, x equals pi over 3 plus pi n. Because pi over 3 plus 3 pi over 3 would be 4 pi over 3, which is what 8 pi over 6 reduces to. So I only need to write that once. Okay, let's do the next one. So x equals 4 pi over 6 would reduce to 2 pi over 3 plus pi n. And looking at this one, if I add pi to 4 pi over 6, I do get 10 pi over 6. So I don't need to write the second ones in the bottom because the period of tangent is pi. This is exclusive to tangent and cotangent. Now I've had students ask me before, well, could I write all four of them and just put plus 2 pi n? Well, you could, but you'd get a lot of duplicated answers and your textbook is not going to write it like that. Does that make sense? I mean, you could, but the textbook is not going to write it like that. Okay. Is everybody all right? Okay, let's take a look at number 5. Okay, so here's where we are adding more on. So this isn't just like solving, getting tangent by itself. It's not just getting, cosine or sine by itself. This is a different technique. And so what we would prefer, for all one trig function. That's our preference. Like I want all sines or all cosines. I don't want a mixture. Now, is it possible to solve with a mixture? Yes, but our preference, if we can, is to get all one trig function. So as we look at sine and cosine squared, now it came up in our work the last time when we were doing the u things. Remember that? All the u's? We were getting rid of the trig functions and putting u's in their place. We were having to use identities. That's what we have to do with solving equations. We're going to have to use identities. So I need to figure out how to either write sine like a cosine or cosine like a sine. And since sine squared plus cosine squared is 1, it would be far easier for me to remove the cosine squared and put in its place. So cosine squared would equal 1 minus sine squared. How did I get that? I just solved for cosine squared. So I'm going to take this 1 minus sine squared and I'm going to put it where the cosine squared is. I'm going to take that out. So I have 1 plus sine of x equals 2 times 1 minus sine squared of x. Okay, that has helped me get one trig function. I'm very happy about that. Now, as we solve, we want to distribute and combine like terms and move everything to the left. So 1 plus sine x equals 2 minus 2 sine squared. So I'm going to move the sine squared over, so 2 sine squared plus sine minus 1 equals 0. Okay, so I'm going to pause for a moment. Is everybody okay? Okay. So here is where, I know you cannot wait to hear this. Here is where we get to factor. Factoring. Yes, nothing ever goes away, ladies. It's always there. So I'm going to rewrite this how we would have seen it last year. Now, you can do this or not. I'm going to write it in a different color. So this would be like 2x squared plus x minus 1 equals 0. This is what it is like. And I have students that really do not want to factor with trig, and they would rather factor like this with just plain old polynomials. It doesn't matter to me which way you do it, ladies. Whatever your preference is, let's do it this way first. So we know the factoring will be 2x and x and 1 and 1. Let's see, the back sign is negative. That means the signs are different. So that would be plus and that would be minus. Okay, so this is what it's like. Now let me show you what we need to write. That's what we're doing, which means that this is 2 sine of x minus 1 times sine of x plus 1 equals 0. Now I'm doing the polynomial the first time that I do factoring with trig functions with you, but I probably won't do it again. But please, if that makes more sense to you, just rewrite it and then put it back. Notice how I took the signs out and put x's in their place, and now I put the signs back in place of the x's. That's fine. When we did this, look at the part in pink. What was our next step after that? What did we do after that? We solve for x, right? We set each factor equal to 0 and solve for x, and that's exactly what we're going to do. We're going to set each factor, so 2 sine x minus 1 is 0, and sine x plus 1 is 0. So let's solve for sine. So 2 sine of x is 1, so sine is 1/2, and sine is negative 1. Okay, so we've worked each piece. We know what sine is supposed to be. Here's where we do our unit circle. We think about our unit circle on both of these so we can figure out what's going on. All right, so let's see, sine is 1/2. That's positive, so we're in the first and second quadrant. Sine being 1/2 means that x is bigger, because sine is y, so these are going to be flatter along the x-axis. And I am sorry I have to say that over and over and over again. I hope that it gets more comfortable for you, because I probably said that 20 times. I don't know, at least 20 times. Okay, this is a 30, 60, 90, so let's count. We have 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. Okay, great. So let's write our general solution. A solution for all is called a general solution. Let's make ourselves a note up here. All is also called, let's just say equals, general solution. That's something that they might ask you as well. What is the general solution? That means you're finding all. Okay. So let's write that out. So I've got x equals pi over 6 plus, what's the period of sine? 2 pi n, and x equals 5 pi over 6 plus 2 pi n. Okay, so those are legitimate, those are good. Now let's tackle the other side. We want sine to be -1, and sine is -1 down here. Okay, so that is x equals 3 pi over 2 plus 2 pi n. All right, how are we doing? Okay, so we've gotten we did a factoring one. Number 6, we've done something like this before. Which numbers is number 6 like? It's on the other page. What numbers is number 6 like? Are we together? Which one is it like? There's 2 of them. Y'all are like, no, I don't know. Yes, like number 3 and like number 2, where we ignore the argument. This is like number 2 and 3. Okay, we're going to ignore the argument. We're going to figure out where is secant equal to 2. We want to know that. And that's, so I don't have secant values memorized, but I sure have cosine values memorized. Okay, this would be when cosine is 1/2. Okay, we're in degrees. Okay, cosine is 1/2, so that's the x value. Cosine is positive, it maps to the x. So we want it to be longer along the y in quadrants 1 and 4. Okay, longer along the y. So let's see, we're in degrees. So that will be 30 degrees, 60 degrees, 90 degrees, that's 180 degrees, that's 270 degrees. So what is that? That's 300 degrees. Okay. So 60 degrees and 300 degrees. And then what do we do? Once we figure out where that is, what do? We set the argument equal to those. Okay. So theta plus 81 degrees equals 60 degrees, and theta plus 81 degrees equals 300 degrees. Okay, so let's work that out. So theta is going to be 60 minus 81. What's that? -21 degrees. And theta is going to be 300 minus 81. What is that? That's 219 degrees. So we're writing general solutions. What is the normal period for secant? 360 or 2 pi, right? So our answers are theta equals -21 degrees plus 360 degrees in, and theta equals 219 degrees plus 360 degrees in. All right. All right, ladies, let's take a look at number 7. Yay. So look at number 7. That kind of looks like the other one that we did, right? With the squares. Okay, it kind of looks like that one. So what do we think we're going to do? Factor. We're going to factor. All right, so here we go. Going to factor. So I'm not going to put the x's in there, but if you need to do that pink step, that extra pink step, please do so. But I'm just going to write 2 sine times sine. The back sign is positive, so the signs have to be the same. The middle is negative, so it has to be a negative, negative. And it has to, 1 times 1 is the only way to, well, not the only way, but this way we're going to get 1. So let's check it out. So 2 sine times sine is 2 sine squared. Minus 2 sine minus 1 sine is a -3 sine. That's perfect. That works. Then we set each factor equal to 0. Okay. Then we solve. 2 sine x is 1, so sine is 1/2, and sine is 1. Now we actually already did sine as 1/2, if you see that right over there to the right. So if that's okay with you, I'm just going to write that down. Okay, instead of redoing it, it's right here, right? It's this part right here. We've already done that part before, so I'm just going to write it down. So x is pi over 6 plus 2 pi n, and x is 5 pi over 6 plus 2 pi n. Okay, good. Now we haven't done one like this where sine is 1. So sine is y and sine is 1 right here. So that would be x is pi over 2 plus 2 pi n. All right, how are we doing? Is everybody okay?